Today you will be solving linear systems of two variables. So a system of linear equations is two equations of the same variables. Typically we will see something like this with the squiggly bracket. You have two equations with the same two variables. So we have three different ways to solve. We will be focusing primarily on substitution and elimination, which should be reviewed from Algebra 1 and Algebra 2. The first thing you'll do with your substitution method is you'll solve one equation for one of the variables. Then you'll substitute that expression into the other equation. Then you'll solve that equation for the remaining variable. And then you'll use back substitution from step 3 into the original equations. Notice we will solve this example using substitution, and we have our steps listed off there on the right. So if we look at our system here, notice it says we are going to solve equation number 2 for x. And the reason why I would suggest doing so is because it's like it says x to the first power. Okay, so what that means is to solve for x, you'll add 2y to both sides. Right? So we'll have x equals -3 plus 2y. If we look at step 2, we're going to substitute the equation from step 1 into the other equation. Okay, so what that means is I'm going to take what x equals and replace it into the other x. Why is my pen being all weird? Okay, so when we do so, we'll have 5 parentheses, -3 plus 2y, close, minus 4y equals 9. Now, if we look at our step 3, now we're going to solve for y. So in order to do so, we'll distribute the 5 through, -15 plus 10y minus 4y equals 9. Combine like terms, -15 plus 6y equals 9. Add 15, so 6y, why is it being weird, equals 9 plus 15 is 24. So y equals 4. So notice that we have in our next step, we're going to substitute y into one of the original equations. Okay, so you really just can pick whichever equation you feel like looks easier. I would probably choose equation 2 because it is easier looking, like the numbers are smaller. So x minus 2y equals -3. Okay, and we're going to put the 4 in for the y. So x minus 2 times 4 equals -3. Okay, so x minus 8 equals 3, or x equals, -3. X equals 5. And the last step is to write your solution as an ordered pair, so we will do that next. So our x is 5 and our y is 4. And that's it. Take a minute and try this example you try. Okay, so hopefully you found the solution for x was 1 and for y -1 using substitution. We are now ready to talk about the elimination, sometimes also referred to as linear combinations or referred to addition method. And it's really not that difficult. The first thing you'll do is you'll make one variable in both equations have the same and opposite have the same and opposite sign coefficients. Okay, so that's the first step. The next step is to add or subtract to eliminate a variable. Then what you'll do is you'll solve for the remaining variables. So if you eliminated x, you'll solve for y. And then you'll use back substitution to find the value, using the value from number 3 into one of the original equations to solve for that remaining variable. So if we look at our next example, we're going to solve the following system using elimination. So if we look at our x's and y's, a couple things that we can notice. We notice already the y's are opposite signs, and we can easily get a common multiple of 8. So if you want to, that's the way I would go instead of doing what this suggests to eliminate the x's first. I would probably choose to eliminate y's. So in order to, when I add them together, I have to change that 2y in equation 1 to an 8y. So we'll multiply equation 1 by 4. Okay, so 12x plus 8y equals, and then 48 times 4. Oh, 144. No. 192. And the bottom equation we left the same. Okay, so if we look at our steps, the next thing we'll do is we'll add down. So we know 12 plus 9 is 21x. The y's cancel out. And 192 minus 24 is 168. And notice the next thing we'll do is we'll solve for y. So we divide by 21. And we do get x to equal 8. Okay, so now we're ready for our next step. We're going to back substitute into one of the original equations, and it does not matter which one you choose. I would probably choose the one that looks easier. I would probably choose equation 1, but you're welcome to choose equation 2 if you would like. Okay, and we're going to put the 8 in for x, so 3 times 8 is 24. Or 2y equals 24, and we get y is equal to 12. The last thing for us to do is to write our solution as an ordered pair. So if x is 8, we'll start with 8, and then 12. The end. Take a minute and try this example you tried. So hopefully for this example, you found your solution to be 1, negative 2. Couple different things for types of solutions. Remember, if there is exactly one ordered pair, then that means your two lines intersect at one point. Because we're solving a linear solution in two variables, the graph of the equation would make a line. So this first graph on the left would have one solution. If there are no solution, then that means we have two parallel lines, because that is the only situation in which lines do not intersect each other. And if we look at the third infinitely many solutions, right, that would mean our two lines are identical. So in our next type of problem, we're going to, solve the system of equations. Because we don't have a 1x or a 1y, I would probably suggest that you use elimination. It does not matter if you get rid of x or y. I would probably choose to get rid of y because 2 and 4 is easier for me to find a common multiple for, and they are also already opposite signs. So we'll actually multiply the first equation by 2. And rewrite the bottom equation. Notice what happens. In this case, both x's and y's cancel out. So we have to say to ourselves, can 0 equal 15? And that is a no. So therefore, our answer is no solution. If we look at this other example, you can use elimination or substitution, it doesn't matter. If it were me, I would probably choose to multiply equation 1 by -5. And -5x plus 20y equals 40. And then equation 2. And then notice what happens this time. X's cancel, y's cancel, so the left side becomes 0, and the 40's cancel. So if you get 0 equal to 0, that is a situation in which you have infinitely solutions. The final type of problem is a story problem, and you will have story problems on the formative and on the summative. But notice we have the sum of two numbers is 7. We have if one number is subtracted from the other, the difference is -1, and we want to find the two numbers. Note in parentheses it says we're going to use a linear system. So my words of wisdom is to read the situation a few times, read carefully, set up two equations, and then solve the resulting system. So we know we have two rando numbers. So if it were me, I would probably say x is the first number, y is the second number. And if I have sum of two numbers, what operation does that mean? Well, that means to add. So we know x plus y is 7. And if one number is subtracted from the other, their difference is -1. Okay, so x minus y is -1. Okay, so now it just becomes a problem for us to solve. Okay, so because the y's are already opposite signs and they have the same coefficient, I would just add straight down. So 2x equals 6, or x equals 3. And then we also know that x plus y equals 7. So 3 plus y equals 7, or y equals 4. So our two and numbers are 3 and 4. Yay. Let's do some practice. The end.